All right, our last lesson for the quadratic functions unit, which lasted 2 weeks long, is super long, are application questions. And I know word problems can be a source of stress for some of you. I recognize that you may not enjoy word problems as much. I'm going to try to break it down and give you recipes to make it as easy and painless as possible. Not that I expect you to memorize anything, but really, I'm going to point out patterns that work almost all the time. So take a look at the very first page. Because we've been talking about parabolas, all of the word problems that we're going to talk about today are going to involve something that is in parabolic motion. And I can give you lots of examples, right? When you kick a soccer ball really, really far, you know that soccer ball flies through the air in a perfect parabolic motion. When you throw a football, again, the same thing. It's that nice parabola. When you fire a firework, imagine you're not firing it straight up, but you're firing it across. The firework also is a perfect parabola. So in the textbook, you're going to notice there are all sorts of examples of like footballs being thrown, soccer balls, fireworks, rockets, tennis balls, etc. Basically, anything that's thrown up into the air is going to follow this motion. So let's break it down. What happens in terms of a graph? On our graph, we're almost always going to have, not almost always, you're either going to have time, distance, depending on what the question is asking for. And we're going to do examples of both. And on the y-axis, almost always it's the height. How high above the ground is this ball traveling? So you can throw a ball and I can ask you questions about the time, like how long did it take to get to the top? How long did it take to get all the way to the other side? Or if I'm looking at football, I can say, well, how far did the person throw it down the line? How high up did it get? So all sorts of questions like that. A couple of things, if we're talking about time, anything on this part of the graph will not count because it's negative, right? So you can't have a negative time. You also can't have a negative horizontal distance. So really, we only look at the positive section of the graph. The y-intercept is really important. At the y-intercept, it means time is 0. So at this stage in the graph, it's the very first thing that's happening. And so this is usually your initial height. So this is the height that the ball is starting off at. The y-intercept tells you the initial height of whatever it is. A question you can ask yourself, or that I might ask you, is how high off the ground did the object start? And when I ask you that, I'm asking you for the y-intercept, the very starting point of that motion. Sophia? But really, do you throw a ball from the ground? Unless it's a soccer ball, it depends on the question, right? If it's a football, no, you're not starting, you're starting maybe a meter off the ground or whatever your height is. So no, it's actually very rare that it starts right at 0, 0. The vertex gives you two very important pieces of information. The x value tells you when is the object at maximum height. And the y value tells you how high the object gets. So for example, let's say this is a ball that's being thrown and this is the time and this is the height. And I tell you the vertex is 2, 10. So that means this number here is 2, this number here is 10, and the maximum height of the ball occurred after 2 seconds, and that maximum height was 10 meters. So the vertex gives you two important pieces of information. It tells you when it reaches the maximum, the highest point, and how high above the ground it is at maximum point. And then finally, this 0 over here, it basically tells you when does the object hit the ground or how long the object was in the air. Okay, so we're going to do a bunch of questions that involve this. Just keep referring back to this diagram if you want just a reference. Okay, so question number 1 says, the flight of one type of rocket at the Symphony of Fire is described by the function h is equal to -9 t minus 5 squared plus 124. Now, I want to tell you one thing. In the textbook, they do use decimals. So when you're doing your textbook questions, if you wanted to use a calculator, you could. But on the test, I've given you like baby numbers, like 2s and 3s and 4s and 5s. So like, I know you don't have a calculator. I'm not going to put anything difficult on there. But obviously with 4.9, if you want to take out your calculator, just because this is a question from the textbook, you can. Where h is the height of the rocket in meters, so how high above is measured in meters, and t is the time in seconds since the rocket was fired. Let's draw a little picture to see what is happening. So I'm going to have my y-axis here. I'm going to have my x-axis here. And I told you guys that if we have time, it's always going to go on the x-axis. So I'm just going to label this time. And if we have height, it's always going to go on the y-axis. And by the way, the time is going to be measured in seconds. And in this case, honestly, I just don't have enough room. So I'm just going to write it like over here. Height is going to be measured in meters. I mean, I could move this over. Sure. And anytime there's time, it's always on the x. Okay, so you don't even have to think about that. Just always put it on the x. Okay, let's analyze this equation a little bit. So I'm going to rewrite it over here. It's h is equal to negative 4.9 t minus 5 squared plus 124. The very first thing everyone should be able to notice is the vertex. What is the vertex in this equation? Angelique? You're really, really close. The only thing I would change is I would not make it a negative 5. I would change the sign and make it a positive 5. Okay, so everything in the bracket here, change the sign. So your vertex is going to be at 5, 124. Okay, let's try to figure out what's happening. We have a rocket. I'm going to say it's probably firing from like somewhere along this line. It goes up and then it comes down. We don't care about negative because like, even though technically this should look like this, there can't be a negative time. So we don't even care about that. We just care about what's happening from time 0 until this moment here. Okay, now the vertex is 5, 124. So this point right here is 5 bracket 124. What does that mean? That means when you go 5 seconds across and then you go up to 124 meters, you're going to get your vertex. This is why I just wanted to write that there, because then I can write the number 5 over here. Okay, I'll repeat that one more time. So our vertex is 5, 124. It means starting from the origin, you're going 5 units this way and 124 units this way. Okay, now using this, any questions about this so far? You may have questions, but just like keep them in your mind while we answer the questions. The question says, what is the maximum height reached by the rocket? So what was the highest this rocket went? Shweta? Perfect. As soon as you figure out the vertex, it's going to give you the maximum height. It's going to be the second number. And all we're going to do is we don't need to show any math. We just need to write down 124 meters. How did we figure that out? It's the y value of your vertex. It's this value right here. Okay. Question B. How many seconds after the rocket was fired does the rocket reach the maximum height? Maggie? Yeah, of course. Krishna, what do you think? Exactly. So the question is asking, like, when did it reach this point here? You just look at your x-axis and you already figured out that the vertex is 5. So after 5 seconds, it's going to reach its maximum height. So again, no need for calculations. You're just reading it off the vertex. If you're someone who likes to write stuff down, this number gives you your maximum height. this number, in this example, every example is slightly different, but this number tells you how long it takes for you to reach that maximum height. Those are the two questions that are the easiest to calculate. I want everyone to make sure you get those perfectly right, because question C is going to require a little bit more work. So question C says, how high was the rocket above the lake when it was fired? So remember, they're firing a rocket on top of a lake. And we assume that they're not firing it from the ground, because to be honest, if you think about it, if you've ever been to Disney World with those huge like firework things, they always have a platform that they're firing from, right? Just to be safe. So we're assuming that this firework was fired from like some point over here. So some point over here, and I want to calculate how high above the ground it was initially fired from. Can you guys tell me what point this is on a graph in terms of like intercepts, Hershey? Yeah, this point right here is your y-intercept. And if you want to calculate your y-intercept, what do you let x equal to? Good, so we're going to let x equal to 0. And when we do that, we're going to get whatever point this is over here. Yeah. Yep, and you're absolutely right. In this question, we don't actually have an x in the equation. We have a letter t. So I'm going to let t equal to 0, and I'm going to solve. And this is the third type of question I'm going to ask you. Like, I'm basically telling you what's on the test. I'm definitely going to ask you how high above the whatever it was fired. That's going to be the y-intercept. You're going to let whatever your x letter is be equal to 0, and then you're going to solve. Yep. Yeah, you're looking for the height by letting t equal to 0. Okay, so here is where we go back to our equation and we write it down, and then we do a couple of calculations. So it's going to be h is equal to negative 4.9. My t is going to be 0 because in this question, your t is essentially your x. And now you're just going to solve this, and it's going to tell you what the height is that it was initially fired at. So negative 4.9, 0 minus 5 is negative 5. Negative 5 squared is 25, plus 124. I won't torture you and make you do this in your mentally, but like I assured you on the test, the numbers are pretty fair. So go ahead, just use your calculator, figure out what negative 4.9 times 25 is, plus 124. Okay, so this gives me 1.5 meters. Imagine the same calculation, but if I have like a -2 or something, then you can definitely do this in your head or on a scrap piece of paper. That's what you're going to do on the test. All right, so how high was the rocket fired above the lake when it was fired? We're just going to say it was 1.5 meters. That means that this point right here is 1.5 meters. I'm going to move this over here, and I'm going to, oh, nope. And I'm just going to write 1.5 meters. Obviously, this is not to scale, because if this to this is 1.5, then this is definitely not 124, but it's just a sketch. All right. An equation that models the flight path of a small shuttle is y is equal to negative blah, 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 where x is the horizontal distance traveled in meters after the shuttle is launched, and y is the height in meters above the ground. So in this question, they're not talking about time. They're basically launching a shuttle, and they're seeing how high it gets this way and how far it gets this way. So they want to measure the horizontal distance, how far it has traveled. Yep. Yes. The number, wait, repeat that one more time. Oh yeah, this doesn't matter. That's why they have decimals, because really you're only looking at the vertex, and in this question the vertex is nice whole numbers. Yeah, so the negative 0.38 doesn't matter until you're finding the initial height. Yeah. Okay, so I have on this side, I'm gonna have my height in meters. And on the x-axis, it's a horizontal distance. Also in meters. Horizontal distance is literally like, you know, when you're watching track and field in the Olympics and they're traveling 100 meters, that's the horizontal distance. Like how much are they traveling from the start line to the finish line this way, horizontally. Okay, so if we were to model this, again, we're assuming it's going to start somewhere along here. It's going to go up and then it's going to come back down. Yep.
If you're drawing the graph, but see how you're drawing the graph in the question, if you give it, it misses out the graph like that.
I did leave a little space for a sketch, yes.
So does it have to be accurate or?
No. Yeah, not looking for accuracy at all because, you know, just no. Yeah. Okay, let's look at this equation and start answering some questions. The first one that I can very obviously and clearly see is the vertex. So in this question, what is the vertex? What do you guys think? Vertex? This one's a really easy one. It's already in vertex form. Say it. Excellent. +10 and +40. So that point that we have just calculated is this one right here. This point is 10, 40. It's the vertex. Well, what does it mean in terms of the numbers? Well, you're going 10 across. So this value right here is a 10. And then you're going all the way up to 40. Basically, what this means is the rocket reaches the maximum height after it has been going 10 meters horizontally, and the maximum height it reaches is 40 meters high. Can you visualize that? Like, does that make sense in your minds? Kind of, yeah. So you're launching a rocket, it reaches the maximum height after it has gone 10 meters this way, and the highest point it's going to go is 40 meters up. Okay, so let's answer some questions based on this information. Question number 1, it says, what is the maximum height reached by the shuttle? No calculations necessary. You're reading it off the graph. So what do you guys think? I see a few hands. I want to hear from someone maybe I haven't heard from. Rahima? The maximum height is 40 meters. Excellent. And so again, just like before, I will label this. This number here gives you your maximum height. Just going to write each one of these numbers after where the actual question is, just so it doesn't get confusing. Okay, there we go. All right. Question number 2, it says, what is the horizontal distance traveled when the shuttle reaches its maximum height? So I want to hear, Saran? 10 meters. So it goes 10 meters horizontally before it reaches a maximum height of 40 meters. You guys notice we didn't do any calculations for that. We just read it off the vertex. So again, this number here in this question is going to tell me, what did I write up here? The time. And then this question, it's going to tell me the horizontal distance. So can I just write HD for horizontal distance? The horizontal distance when the ball is at the maximum. Okay, let's keep going. Question C. What is the initial height of the shuttle? At what height above the ground was the shuttle launched? Show your work algebraically. So let's just go to our graph for a second over here. Our initial height is going to be this value right here. And just like before, we know the initial height is the y-intercept. So you're going to let your x value equal to 0 and you're going to solve. We again have a decimal, so we're going to use, we might not have to use a calculator because actually you're multiplying by 10. So let's try to challenge ourselves and do it without one. So I'm going to start off with the equation, which is going to be y is equal to negative 0.38. And it's going to be, over here, I'm going to put 0 minus 10 squared plus 40. Okay, and if you want to make a note to yourself, when you're finding the initial height, this is your y-intercept. So you're letting x equal to 0. And you can only do this algebraically. You can't read it off the graph. All right, let's finish this. 0.38. 0 minus 10 is negative 10. Negative 10 squared is 100 plus 40. This question is odd. So it's going to be negative 38, because if I'm multiplying by 100, I'm basically just moving the decimal place over twice. You don't even need a calculator for this. And I end up getting 2 meters. If you want to confirm with a calculator, go ahead and tell me if you get the same thing. Do you guys get the same thing with the calculator? 2 meters. So on my graph, if I go back here, it means that I launched this shuttle from 2 meters above the ground. Okay, always assume it's not 0, 0, it's 2 meters above the ground. Last question before we go on our break. We'll do the third question after the break. Let's do question. Oh, I'm not going to do E. E is like a super challenge. We're going to skip that. I didn't put it on the test or anything, so we can ignore that. How high is the shuttle after it has traveled a horizontal distance of 5 meters? Show your work algebraically. So what exactly is this question asking? It's saying, okay, well, this is 0 meters horizontal, right? Then here is 10 meters. If I travel 5 meters, how high above the ground have I gone? So I need to use my equation. Where am I going to put this 5 in? Am I going to put it into the y or the x? Hershey? Yeah, it's basically saying when x is equal to 5, what is y going to be equal to? So this is algebra work again. You don't need to, so we're just going to put it into our equation. Y is equal to negative 0.38. And basically this question is saying x is equal to 5 meters. So I'm going to put 5 minus 10 squared plus 40. 5 take away 10 is 5. 5 squared is 25. This one you probably may need a calculator. So 0.38 negative times 25 plus 40. Let me know what you guys get. What'd you guys get? Nope, not quite. 30.5 meters. So we can say, therefore, I'm not even writing full sentences. How high? The shuttle is 30.5 meters high. And on the graph, it means that after 5 seconds, if you were to like go up, this point right here should be approximately 30.5 meters high. Okay, and like I said, we're going to cancel E. Pause the recording. In meters above the water, in terms of our horizontal distance, x in meters from the end of the board is given by this equation. The first thing I'm going to ask you is, what form is this equation in? Standard, vertex, or factored? Standard, which is unfortunate, because if you take a look at the other two examples, what form I don't know when it cut out, but basically we're just saying, yeah, so this isn't standard form. And in the previous examples, everything is easy. So we definitely need to do an additional step now, and it is convert this equation from standard form into vertex form. So go ahead and try that because we already did an example today. Do it yourselves. I'll do it on the screen, and then we can see if we get the same answer. Okay, now we finally have an equation in vertex form. Let's just really quickly talk about what's happening here. There is a person and they are at a pool and there is a diving board, and this person is standing on the top of a diving board and they are about to jump and dive into the water. So obviously that diving board is not at 0, 0, it's above the ground, and this is the motion that they're taking. Looks like they're peeing into the water, but we're just going to pretend like that's them actually diving in. Let's actually, there's a grid here. I didn't give you a grid on a test. I'm okay if there's just a sketch. Oh, you don't even see my funny drawing yet. Wait, it's coming. And then you're going to see what I'm laughing about. Let's go ahead and draw some, or let's just point out some of the interesting facts on here. Oh, come on. Died. Here too. Here, oh, it's coming up. So I'm just going to pause the recording there. So this is the person I drew. This is the diving board. This is the person on the diving board. They're about to jump into the water. Now, if we were to actually put this information on a graph, we know that the vertex is going to be at 1. Oh, actually, you'd let me know. What is the vertex going to be at? Kind of gave it away there, Rahima. Yeah, so the vertex is going to be at 1, 4, which is about here. We don't know where the person starts at, and eventually we are going to calculate it. So I'm going to finish this diagram off in a bit once I know my exact value here and here. Okay, so I'm going to actually sketch this graph probably a little bit later. Okay. What was the Danielle's maximum height? So I do know that if I were to sketch this just in a rough manner, her flight would be something as follows. So it's going to go like this, and then it's going to go like this. So what is the highest point that she's going to get to? Krishna? Yeah, it's going to be 4 meters. And so just like before, you should know that this number over here, actually, I'll just move this vertex over to this page. This number over here, the 4, tells me my maximum height. At what horizontal distance did Danielle reach her maximum height? So we know that her maximum height over here is going to be 4 meters. But how far from the diving board did she reach? And this isn't very accurate. Assume that she's like right over here. How far this way did it take for her to reach that maximum height, Saphir? Yeah, it's just going to be 1 meter. It's going to be this number over here. By the third example, I'm hoping you guys see the pattern and the trend. From what height did Danielle dive into the water? So what are we going to do there? We're going to figure out this value right here, which is your initial height. And that initial height is also your y-intercept. To calculate that, you let x equal to 0. Shweta? You can't have a negative height, distance. Exactly. Yeah. So as soon as you figure out the vertex, this tells you how high the person got. This tells you how long it took or what distance it took. Then you've done something wrong. You've done something wrong. So that's actually a really good point. What if your vertex ends up being -1, 4? In this scenario, it means you've completed the square incorrectly. It has to be positive. Yeah. All right. So now what we're going to do is we're going to take our equation, which is y is equal to negative bracket x minus 1 squared plus 4. Now here's the thing, and I don't want to confuse you guys. So I'm going to show you this question in 2 different ways. We're going to do exactly what we've been doing in the past. We're going to let x equal to 0, and we're going to solve this. And these are the types of numbers you're going to get on your test. No calculator needed. You should be able to do this just like mentally. So this is going to be 0 minus 1 squared plus 4. -1 squared is +1. -1 plus 4 is just going to give me 3 meters. And I'm just going to make a note that this value that they're asking for is your initial height, which is your y-intercept, and you're always going to let your whatever your x value is equal to 0. I did not like how I wrote that, so I'm just going to write it again. Okay. Now let's go back to this. What does this mean exactly in my very, very rough and not nice sketch? Well, the highest point they got to is 4 meters, and they started from a height of 3 meters. And this makes sense. If you guys watch the Olympics, diving is always at 4 meters and 10 meters. So 4 meters is that springboard. That's the lower one. And so that's what she's jumping off at. When she jumps up, does it make sense that she would only jump up a meter? How many feet is a meter? Anyone know? A meter is actually, just think of a meter stick. It's this much. So yeah, it's actually very possible that with a springboard, she was able to jump this height before and reach her maximum height. That's actually a very, that's a pretty accurate or like realistic number. Okay, so she started at 3 meters. The highest she got was 4 meters, and it took her 1 meter across this way to get to that height, which also makes sense, right? You can jump a meter very easily. All right, now I'm going to show you guys something kind of cool. You know how we figured out our initial height using this equation? What if we use the original equation? So let's say I did this question and I recognize that I actually have the equation in standard form. Remember, standard form is important for one thing, and that one thing is the y-intercept. So if the original equation of y is equal to negative x squared plus 2x plus 3, this is just going to become a 0. This will become a 0, and you're left with just 3 meters. So it doesn't matter which equation you use, but if you have standard form, that's always easiest to figure out the y-intercept. Okay, 2 more questions. Question E says, at what horizontal distance did Danielle enter the water? And we can actually calculate this. It's not a challenge. Now, if you look at your parabola, Danielle is diving. She's diving this way. We don't look at anything in the negative. But really, what are these 2 points in the parabola called? Yeah, these are your x-intercepts. So we're going to figure out the x-intercepts. One of them will be negative, which we're going to not count because you can't have a negative distance. And whatever the positive x-intercept is, that's the point where she enters the water from the origin of 0. So it takes her 1 meter to get to the maximum height. We're going to try to figure out at how many meters does it take for her to go into the water. Anyone want to take an educated guess of what that number might be? If the vertex was 1 meter and the vertex is right in the middle, actually, you know what? Pause that. Let's not do that. So let's look at the equation in standard form. Y is equal to negative x squared plus 2x plus 3. How do I figure out the x-intercepts using this form, Jennifer? I'm going to factor it. So let's first take out the factor of negative. A nice simple trinomial. All right, so we have two x-intercepts. One of them is x is equal to 3, and the other one is x is equal to -1. Which horizontal distance does not make sense in this question? Yep. Yeah, obviously you can't have a -1 distance. So it basically means that the horizontal distance that Danielle entered the water was also 3 meters. So therefore, horizontal distance of 3 meters. Going back to our diagram, all this means is if it took her 1 meter to get to the highest point, it took her 3 meters from the starting point to get all the way to the end over here. And that means the other point is -1, but obviously we don't look at a negative distance. Okay, last question. How high is Danielle after she has traveled a horizontal distance of 2 meters? So what this question is saying, okay, so now we know 1 meter is the highest point. We know 3 meters is when she enters the water, but approximately at 2 meters, what is her height over here? So how high has she traveled at over here? How do we calculate that? How do we figure out the height when her horizontal distance is 2 meters? Amina? Yeah, you just plug 2 into the x. Does it matter which equation we use? It doesn't. You can use the factored form or the original or the vertex. We actually have all 3 forms here. We have standard, we have vertex, and we have factored form. I'm just going to go ahead and put it into my standard form because I have it in front of me here. So negative x squared plus 2x plus 3. And we're basically in this question, we're going to let x equal to 2 meters. So question saying when she's traveled 2 meters across, how high is she? What's her y? So it's going to be negative 2 squared plus 2 times 2 plus 3, negative 4 plus 4 plus 3. And so I end up getting 3 meters. Therefore, she is 3 meters high after traveling a distance of 2 meters horizontally. I haven't been really good, you guys, with my therefore statements and stuff like that. And I'll be pretty easygoing on the test as long as you like box your answers and I can clearly see them. Okay, I bet you are dying to start some practice questions. There are a ton of practice questions in the textbook. And in tomorrow's class, I'm also going to leave a worksheet with these questions for you to practice doing. So you can go ahead and get started on those now.